Now let's do some Snell's law problems. Remember, Snell's law says if you have a medium between two materials, if you have a barrier, and you have light ray coming in, it will be refracted toward or away from the normal with a very specific relationship. If theta I is your incident angle, where we always measure with respect to the normal, and this is some material n sub I that has some index of refraction n sub I, and this is my refracted nr, and this is my theta r. So ni is my incident angle in my incident material, theta r is my refracted angle in my refracting material. Snell's law says ni sine theta I must equal nr sine theta r. Now, the biggest problem with these is you have to remember you must be in degrees on your calculator. Now, suppose I have a light ray that has a wavelength of 589 nanometers. So, lambda is 589 nanometers. Traveling through air, so this is air. So Ni is 1, because I know the index of refraction of air is always 1. And it hits a flat slab of crown glass at an angle of 30 degrees. So theta I is 30 degrees. The index of refraction of crown glass is 1.52. So NR is 1.52. Find theta R. Okay, so you write out your given. Ni is 1, which is air. Theta I is 30 degrees. And NR is 1.52. Snell's law says Ni sine theta I is NR sine theta R. Just go on and plug your numbers in. Ni is 1, sine of 30 has to equal 1.52 sine theta R. Now, the trick on these is, how do you put these in your calculator? And the answer is very carefully. All right. Go ahead and divide both sides by 1.52. So you have sine of theta R is sine of 30. Now this is a simple one, but I'm going to leave it in like this just so you can see how to do this. Divided by 1.52. Okay, you get this number right here and then put inverse sine, sine inverse, okay, of your answer. And when you get that, you're going to get 19.2 degrees. Now, for each of the following cases, will the light rays be bent toward or away from the normal? Now, here's the trick. Remember, all right, suppose I've got, let me go from like this, all right? All right. This is like going from air to water. So if Ni, the incident ray, is greater than the refracted ray, it doesn't matter what theta is, by the way, it's always going to be away. So this is always the faster, and this is always the slower, and this is always going to be the smaller n, and this is always going to be the larger n. So if Ni is greater than Nr, then which one is larger? Okay, it's this situation right here. It's going from the bottom to the top, so it's going to bend away from the normal. What if Ni is less than Nr? So the smaller n, larger n, it's going to bend toward the normal. Okay, this is going to be away This is toward. Now what about from air to glass? Air has a smaller N than glass. So going from air to glass, it's going to go toward the normal. Going from glass to air, since glass has a larger N, it's going to bend away from the normal.